I want to look at defining vector-valued functions. As an example, let's look at this function r of t equal to cosine of t sine of t. And I want to let t be all the values between 0 and 2 pi. So each of these are vectors, and I want to think about where the vector terminates for each point. If I consider t equal to 0, cosine of 0 is 1, and sine of 0 is 0. So that would be approximately this vector here. If I look at pi over 2, cosine of pi over 2 is 0, and sine of pi over 2 is 1. So that would be the vector 0, 1. If I look at pi, cosine of pi is negative 1, and sine of pi is 0. That would be the vector negative 1, 0. And if I look at 3 pi over 2, cosine of 3 pi over 2 is 0, sine of 3 pi over 2 is negative 1. So I start to have these points. I can also start to look at points in between, like pi over 4. Cosine of pi over 4 is square root of 2 over 2, and sine of pi over 4 is also square root of 2 over 2. Over here, we would have negative square root of 2, square root of 2, negative square root of 2, negative square root of 2, and square root of 2, negative square root of 2. And as we keep filling in more and more values and keep plugging in different values, we can see that we are actually going to map out a circle. And my drawing isn't perfect, but this should end up being a circle. If I think about all of the terminal points of these vectors for different values of t, we would end up with a circle. This example was an idea of a vector-valued function. A more precise definition, it's a collection of terminal points of vectors that start at the origin. My input for these functions is a scalar. We input a single number, and our output is a vector. So we input one number, and we will output a vector. We tend to denote our input by the letter t, and we call this a parameter. There are a lot of examples of common vector-valued functions, but we're just going to look at a few. We've already looked at cosine t sine t. This time, let's consider sine t cosine t. Here I have my graph. As I plug in 0, sine of 0 is 0, and cosine of 0 is 1. So that would be the vector 0, 1. Plugging in pi over 2, sine of pi over 2 is 1, and cosine of pi over 2 is 0. So that would be the vector 1, 0. Sine of pi is 0, and cosine of pi is negative 1, so that would be 0, negative 1. And then sine of 3 pi over 2 is negative 1, and cosine of 3 pi over 2 is 0, so that would be this vector here. And we can look at filling in pieces in the middle, and it turns out this is going to look the same as cosine t sine t when I'm done, although it is slightly different because instead of starting at the x-axis and moving around, this time we're starting at the y-axis and we're moving clockwise in our circle. I can also define this for three-dimensional vectors. As an example, cosine t sine t t. I can still pick values of t and plug them in and determine the defining vectors. However, it may be more helpful to use technology to help me plot it. Here is this function plotted. The cosine t sine t, as we saw before, gives me a circle in 2 dimensions, and this t in my third dimension just kind of stretches this graph out vertically. so it makes it more of a spiral.